Good morning, dear students. Welcome to my channel. It's my first lecture of 10th class from Punjab School Education Board. Today, we are going to study the chapter number 1, Real Numbers. Initially in exercise 1.1, there's an algorithm which is called Euclid's division lemma. We are going to study this. Euclid division lemma stands for Euclid is the name of the mathematician. Division we all know when we divide some number with some other number, and lemma is the process, is the algorithm in which we solve the problems step by step. Before we go to the definitions of Euclid's lemma, let us do some practical examples. We are going to divide some positive integers with some other positive integers. Let us take the first example where a is 18 and b equals to 7. Simply we'll divide like this, as we have learnt in our previous classes. Let us divide 18 by 7. 7 twos are 14 and we are left with 4. Here we can say this is dividend like B, this is quotient Q, this is remainder R, and this is dividend A. Now let us do another example. When A is 17 and B is 6. So let us divide it again. 17 divided by 6, 6 to 12. Again, third example where A is 5 and B is 12. As we can see here, the divisor is greater than the dividend, so we will not able to divide this. And there is one more example. When A is 20 and B is 4. Let us divide this. 20 divided by 4. So in these 4 examples, let us write this in the form, because we have divided A by B, so we can write it as A equals to B multiply Q and plus R, as 18 equals to 7 multiply 2 plus R is 4 here. If we multiply 7 by 2, we'll get 14 plus 4, 18, we'll get the left hand side here. Similarly, we can write the other sums like A is 17 here, and we'll multiply 6 by 2 and add 5. In the same way, A plus BQ plus A equals to BQ plus R, where A is 5 equals to 12 multiply 0 plus 5, and A is 20 and 4 multiply 5 plus 0. As we can see here in question number 1, the remainder r, which is less than b. What is b here? 7, and is greater than 0 or equal to 0. We can say it's greater than 0. It will complete one condition at least, either r is greater than 0 or r equals to 0. In second question, r is less than b, that is 6, and also greater than 0, or we can apply this. And in third question, it is r is less than b but greater than 0, and here r is less than 4 greater than here it's equals to 0. So we conclude from these 4 examples that we are taking any two positive integers a and b, then there must exist two unique values that are q and r, that means quotient and remainder, such that r will always lie between 0 to b. This is our statement of Euclid's division lemma. Given positive integers a and b, if we are taking two positive integers a and b, then there must exist two whole numbers q and r. Why whole numbers? Because 0 can also be included in that. So we conclude that if we divide any number with other number, we can express the process in Euclid's lemma, that is a is equal to bq plus r. This Euclid lemma is used in division or to find the HCF, highest common factor of any two numbers, two or more numbers also. So we'll find HCF by Euclid's lemma in our second lecture. Thank you.